So now, Stan, the ability of systems to communicate really is like the most important aspect of industrial IoT, and that's probably the reason why we've seen many connectivity technologies being developed over the years. Now, to help system designers understand and choose the right standard, the Industrial Internet Consortium, which is an organization of which you are a member, came up with the Industrial Internet Connectivity Framework. Okay, so could you describe to us what the Industrial Internet Connectivity Framework is all about?
Yeah, so back when the IoT was young, this was 2014 or 2015, when the IIC was founded, we realized one of the big problems is people just didn't understand all the different protocols. I put protocols in quotes because calling some of these technologies protocols isn't very fair at all. And so we set off on a project to better understand them, and more importantly, help people understand when they should use different ones. And that was an interesting journey, to say the least. So we ended up looking at 6 different things: so DDS, OPC UA, RESTful HTTP, MQTT, something called CoAP, and we wanted to really understand how they what they actually did, and how they another thing called 1M to M, which is a different kind of technology, really. What they really were, how they interacted, if they interacted, maybe a vision for the future, how they could all work together. And when we started out, I actually wrote a paper, and got it published in a journal about how all these different technologies overlap in different areas, and we put together a 10-dimensional space of things you should look at, like latency and bandwidth and scalability and all these kinds of things. And I thought that they would overlap, and you would, narrow it down to a couple of different technologies and then choose them based on some other thing like cost or performance or something like that. And what we found out instead is that these technologies are amazingly different. They evolved out of completely different environments for completely different use cases, to the point where we even had a problem just classifying them as types of technologies. So we basically ended up with a new stack and a new sort of way to think of a way to think of how you build an architecture. I won't even call it for connectivity, but for a distributed system. And I sort of come to the conclusion there's really 3 different kinds of distributed systems. The IoT is not one thing. Internet of Things, unless you want to call it the future of all technology, which is a bit much. It's not one thing. It's 3 things, my humble opinion. Okay. And the first thing we call device monitoring, which is really a single device. You could have a lot of them, but a single type of device talking to a single cloud service. And that's all it does. So think, Nest thermostats and Ring doorbells, and there may be different kinds of Ring. There's Ring doorbells and Ring alarms, and lots of different devices like that. But they all talk to one cloud service, and they don't do much else. So from a connectivity architecture point of view, it's very simple. It's just a one-to-one connection. So that's the first class. The second class is very different. You take a big existing plant or an oil pipeline or some big system like that, and you put sensors all over it, and you collect those sensors up in the cloud, and do some kind of analysis, maybe a big data analysis or just a display for people. And we call that analytic optimization because what you're really trying to do is analyze what's going on in an existing system. You typically don't change that system. Small changes, you're instrumenting a power plant or something like that. Big market. You'd think it would be the first market. The entire consumer internet is in the device monitoring market. Most of the big companies went after this analytic optimization market because you can immediately install it on existing plants, and that makes it a big market. So you'll think, Siemens MindSphere and what used to be GE Predix and is now just Predix. Somebody else bought it, and most of the technologies out there really fit into the second category, which is all about getting data and being smart about that data. And then there's a third category that I think is the most exciting, but the least mature, which we call edge autonomy, which is basically taking artificial intelligence out of the cloud and making it work in the real world in a way that it doesn't work today. And the applications you've heard of here are things like autonomous cars and, what else might you have heard of? Flying cars and, but there's many other kinds of things. That's where my company exists, is really in the edge autonomy, and we do everything from forklifts to trucks to wind turbines to medical device integration to robotics to intelligent fish farms. And it's just a very big array of things that you can add intelligence to AI, not in the cloud, out in the real world, and make a smart distributed system. So you sort of have to understand that. And then you look at these other technologies, and we split them. We built a stack that's based on interoperability rather than based on the very simple descriptions of the enterprise stack, which is, there's a famous thing called the 7-layer model. The first 3 layers are really just how you get bytes around, and that's fine. We didn't change any of that. But above those layers, we try to look at what's really important. And what's really important in this world comes down to interoperability. And what's important about interoperability is what's interoperable. So the word interoperability is a very popular word in the Internet of Things. You'll hear it every paper, everything we talk about. I don't like the word without the word between after it. So interoperability between devices and a network is a very different thing than interoperability between software modules and a big design is a very different thing between interoperability between machines on a factory floor. And they're just completely different concepts. So we try to, we're just looking at the networking and really architecture. We sort of define 3 levels of interoperability, which is technical interoperability, which you can share opaque blocks of data, and syntactic interoperability, you can share data types, and then semantic operability, you can share meanings of data types. Anyhow, it's a long answer to your relatively simple question, so I'll back off now. But we really had to completely redesign. The framework designs a whole new stack, and it also goes in and analyzes all these technologies and proposes a potential future where we can connect them together where we would need to.
Okay.